So continuing with graphs in ggplot 2, we're going to talk about bar graphs in this lecture. For these graphs, we're going to use the Titanic dataset, which comes in the HIST data package. So we've got to load up our two libraries that we're going to need. So we're going to need to load ggplot2 and HIST data. Now, just to remind you what the Titanic data frame looks like, we've got a couple different categories. We've got class, sex, age, whether or not they survived, and the frequency with which we see that combination of elements. So the first thing I'm going to do is I'm going to try and find the names of the columns so that we know what to refer to when we're making our graph. But as you can see, it gives me a null result. And the reason it does that is because Titanic is not a data frame. And if we look it up using the str function, we can see that it calls it a table, and that's a different thing than a data frame. And we can't really use that. So all we're going to do is we're going to say as.data.frame Titanic, and it's going to transform this into a data table. And we're going to save it as table Titanic as a new variable. When you ran that, it should have appeared here. And now it shows that these are factors. Instead of below, it says they're just characters. Now they're all factors, which is exactly what we want. So if we run str table Titanic, then we can see it's a data frame, and each of these are factors. And that's exactly what we need in order to graph it. So first we're going to look at a very basic bar graph, and you'll recognize this syntax from before. All ggplot graphs have the same thing, where we write ggplot. All graphs in this package have the same kind of syntax to start with. You write ggplot, and then you have your data as the first element, then your aesthetics, which are your x and y, and then you add on things till it know what kind of graph you want. So for us, we're going to use the table Titanic data. We want sex on the x-axis and frequency on the y-axis, and then we're going to say we want a bar graph, so we're going to say geom_bar, and then we're going to write stat equals identity, and I'll explain why we do this later. But for now, we're going to run this, and we get a super basic bar graph of how many men and how many women survived the Titanic. Now, this is pretty boring. It's just black, whatever. But what if we want to have different colors represent the different classes of passenger on the ship? So we can do that. We can map the class of the passenger to different fill colors. And you can see the first line is almost the same, but we're actually going into this main ggplot data and we're saying fill equals class. And so what ours is going to do is it's going to automatically assign a different color to each class, each level of that factor. So if we look back down when we looked up table Titanic down here, if you look at class, it says a factor with 4 levels. So those 4 levels, first, second, third, and crew, it's going to assign a different color to each of those and then graph that on this graph. And then the other thing that we add on to this is position equals position dodge. And you'll see what this does. It's going to create a different bar for each of these classes. So if we run this, it gives us a really pretty graph. So the position dodge, what it does is normally if we didn't have this, I'll show you what it does if we don't have this in there. That's what it would look like without position dodge. And that's pretty ugly. It's because the classes are grouped in different sections in the data frame itself, and it doesn't know to combine all the blue or all the red. And it looks really nice if we just have them separated anyway. So position dodge moves all the bars to the sides. I've just done one more example here. I've done the fills by age instead of class. So now we only have 2 colors. We have child and adult and 4 bars. Now I'm going to talk about stat equals identity, which as you recall we put in the geom bar add-on, and stat equals bin. So if I were to just leave geom bar empty, if I were to take that out entirely, actually what it would be doing is the same as if I had stat equals bin, because R defaults to saying this is true. And what this does is it makes the bar here represent the count of that number. So if you know what a histogram is, it basically makes it a histogram. So let's view our table Titanic data just as an example of this. So instead of saying, okay, for this row, it's a 13, so I'm going to count that as a bar, which is 13, it's going to say here's a 13, and here's a 13, and here's a 13. So that's 3, so I'm going to count a bar as 3. So stat equals bin makes the bar represent how many of those numbers there are. Stat equals identity is when you want that 13 to represent the actual number. You want it to say, okay, there's 13 here, 13 there, 13 there, but they're all adult females, so we're going to do 13 times 3 and add it up in that bar. So that's the difference there. And usually for bar plots, you will always want to put stat equals identity in there because we have a histogram function as well. And if you want a histogram, you'll probably want to use that. The last thing I'm going to do here is I want to change the scale on the bottom. So instead of saying male and female, it says men and women, and I can put an N value in. So the way to do this is it's just an add-on, so it's going to be another plus something. And I'm going to say plus scale underscore x underscore discrete. And in my limits section, I'm going to write out the names of the labels that are already there in quotation marks. So male and female are already there. And then in the labels section, I'm going to say what I want them to be. So I want men, and then this, remember this backslash n makes a new line, and then I want an n equals and an n equals for women. And in just a second, we're going to find out those n values. But if I add this onto the plot and then run it, see, it then changes the labels on my x-axis. But now I want to find out those n values. An n value just represents the number of elements within a thing. So we can see how many men and boys died. But what if I want the total number included in both of these? So the way I've done this is I've subsetted my data. If you think back to our subsetting of vectors videos, this is exactly what I did. I made 2 new data frames, one called Titanic F for female and one called Titanic M for male. In the Titanic F vector, we've got table Titanic and rows where table Titanic in the sex column equals female. So that's giving me a subset of just rows that are female. So this is what this looks like. It's made me a new data frame, and you can see all of these are only female. And I've done the exact same thing and replaced that with male. And then to find the total number of women, if you look back, we've got this frequency column. What we want is to add up all the numbers in the frequency column. And that's super easy. It's just the sum function. And we say sum of Titanic F when the column is frequency. So that's summing that whole column. And it just outputs 470, which is the total number of women. So we can input that, 470. And then we'll do the same thing for Titanic M. That's 1731. And now we can run this code again. And now we have our n values in the labels. So that's it for basic bar graphs and how to manipulate them a little bit. We'll be expanding on what we've learned here and making more advanced bar graphs as we move forward.